What about depth first search in graphs? You might not know it, but you just learned how to solve a maze using programming. Because depth first search is exactly like solving a maze, right? If you've ever done a real-life maze yourself or looked at a program that tries to solve which path to take, the idea was to go as deep as you can, and when you hit a roadblock or a place where you can't go anymore, you backtrack and find a different route. And then you keep backtracking until you find the desired node or you exit the maze. And that's the beauty of depth first search. You can now implement an algorithm that solves a maze puzzle. Isn't that cool? Just like in here, if we do a depth first search, let's say we're starting at number 1 and 10 is the exit or 9 is the exit. And actually 1 won't work because this, unlike our previous graph, which was undirected, that is, it had both directions, I can go back and forth. This one is a directed graph that has specific directions that it can go. So let's do 0 to 9. If I do depth first search and do 9, or we'll start at 0, trying to find 9. Just like looking through a maze, I go here, I keep going through my children, and then try and go as deep as I can. And I manage to get out of the maze before I even search 6 and 5 over here. And obviously this algorithm keeps going because I didn't tell it to stop at 9. But you see how it was exactly like solving a maze. And that's why we use recursion for depth first search, right? The idea of backtracking after a dead end and then repeating the walk down another path is just recursion. Each step smaller than the other, and then we go back and then keep doing the same thing over and over. The idea of depth first search is that it's really good at saying, does the path exist? It doesn't tell us the shortest path, but whether it even exists. And it uses less memory than depth first search. The one downside with it is that if you have a really, really deep graph, then it can get very slow because the deeper the graph, the more recursive calls, the more space complexity you add because we have to keep track of those function calls on a stack.